Hello everyone. Welcome to the Digis Tech Talk, uh, Digis Tech Talk episode 3. Today we are talking about system architecture overview, and I'm Sandun Rathsara, tech lead at Digis. And today what we are going, so let's get started with the presentation. System architecture overview. So what is system architecture? In the IT industry, system architecture is a blueprint of designing, implementing, and maintaining complex software systems. So why do we need software architecture? Because we need to manage complexity and we need to balance the competing requirements and we need to align the system with the business requirement. So we need to have a blueprint before we start the implementation to get the things started, because halfway the development it is very hard for us to do any modifications, any changes for the structure of the system. So in order to manage that structure properly in a scalable and a reliable manner, we need to have a blueprint of the system before we start developing a system. So by using a software architect, we by architecting a software beforehand to start the development, we have some benefits for it. So what we are targeting is to increase the stakeholder satisfaction. We can increase the stakeholder satisfaction by scalability and performance, and we can reduce the time and cost for development, and also the maintainability of the system is greatly enhanced, and it has a better understanding for the system with the software architecture. So how are we going to do that? So this is the main focus of this system, the C4 model. We are using C4 model to demonstrate how we are going to architect a system before we start the development. So with a system, the C4 model, what is it focused on? C4 model is a set of hierarchical abstractions and diagram, uh, abstraction and diagram. This is independent of notation or tooling. What this means is, so in this C4 model concept, it's a hierarchical approach that we are following. So we will explain that in the next in the next slides. Uh, Independent of notation or tooling. So what this means is this method is a concept. It doesn't have any specific notations that we have to follow or specific tools that we have to use. Because of that, it makes using this C4 model for software architecturing very easy. It reduces the learning curve for new people to use this. So this is pretty simple compared to traditional ways of architecting a software which is using just UML diagrams and only going with that. So this is a very uh, organized and simple way that we can use to architect a software. So let's discuss about the concept in here. It's very simple. Start from the highest possible overview and zoom into the lowest possible bottom. So to get started with, I will use a simple example, which is the same example that the C4 model original website explains, which is Google Map. So if you see in here, this is the Earth. So what you can see here is just the names of countries. So you are seeing the whole world as it is. So we can zoom into one country uh, one time at a time. So once we zoom into a single country, we can see main cities in the country like this, and we should be able to zoom further in. So the further we are going to zoom in, we will see few more details about the area. So for example, in Colombo, we can see multiple things that we can go or that there is. So like this, what we are trying to do in C4 model is we decide what is the highest possible overview of the system, what is the environment of it, and from there onwards we zoom into the details. So to do that, there are 4 levels. First level is context diagram. So this is the starting point, the highest possible view. So in this context diagram, we will be considering the system as a single component and all the other external parties that will be interacting with it. So I will explain this furthermore in the next slides. The next level is container diagram. Now this is zoomed into the container diagram, context diagram. So uh, now the software system that we are going to develop is the main component inside the context diagram. So inside the content diagram, we are zooming into the software system and we keep the external systems or parties as it is. I will show those in upcoming slides. And in the next level, we will be furthermore zooming into the individual container and see what's inside. And the fourth one, which is code diagram, this is optional. This is usually replaced by coding. uh, what we do is we zoom into a specific component inside it and we furthermore evaluate the details and diagramming. Now this is optional because in the code diagram level it is too technical and our goal in here is to keep an architecture of the system, and the coding itself can change over time because most of software products these days are following uh, incremental development. So over time, the code level is rapidly changing, and it is not mandatory to design the diagram in this architecture level. We just have to have this first 3 layers. If this is required in a place where like uh, we have to design, let's say we have to do something, uh, we, we faced a situation where we have to debug the system and how the flow is going on. So in that case, we can use this system to drop out specific codes and use the just interfaces and methods in classes and map those with each other and identify an issue or explain it to some other uh, new company or team who's taking over the system. We can use this code diagram. Okay, so let's dive into the C4 model. So I will take a support ticket system as an example. So this is the context diagram for it. So this is a very simple system where uh, the system can only create tickets and update the status of them. And then there's a user management part where we can add new support agents and deactivate them or reactivate them, things like that. So in this context diagram, as we can see, we have identified the support system as a separate component and all the other parties where it gets interacted with the support system. Now this shape, uh, user-like shape, this doesn't has to be this. It just has to imply that this is a person who will be interacting with the system. So in here, I have mentioned this person as support agent. He's the person who will be using this system and interact with the support system. So we are using for the authentication part, we are using Keycloak, and to send out emails, we are using email system. And so this is the simple context diagram. We can use this to uh, give knowledge of the system to some other person, and we can keep this as a reference for the development. So this is too high uh, to start the development, so we have to deep dive into the support system level. So this is container diagram. So inside here, as you can see, this container diagram is zoomed into the support system part. So in here, we are mentioning uh, what are the components inside the support system that we are going to develop. For example, single page application is going to be there to provide the UI for the support agent to interact with the system. And there's going to be an API which will be handling all the data that's coming from a single page application from the front end. And then there will be a database that will be used to store the data and store the data. So after that, we are going to further zoom into this component diagram. So inside here, now we are going to dive into each and every container in the container diagram. So in this container diagram, we have a support system. And inside the support system, these are the containers: single page application, API application, and database. So in most cases, database is not going to be uh, dived into or zoomed in, because it's most probably database is we are going to use a service or something like that, and we don't need to dive into that. We are not going to do any changes for it. So the things that we are going to do changes, we are going to zoom in. So for this example, I will zoom into the API application because it has more components than a single page application. So since this is a simple uh, application with just only ticketing capabilities, it has a auth guard which acts as the verification for JWT tokens that has been granted by the key clock for the user, and it will decide whether the request is valid or not. And after that, after that, it will be forwarding the request to the next level. So the next level is handling the validations and data. So in that case, we have a user controller to validate the data of user endpoints, create, update, or delete. And we have a ticket controller to validate the data of ticket, to create tickets, update status, and comment likewise. And it uses another service, user service, and for the ticket controller, ticket service, which manages the data in the database. Now there can be multiple methods inside the service, and we do separate things, but we are not going to go deep into those in this level. This is only to identify the components inside the container. So we have an email service additionally, which does not have a controller because usually other services use email service to send emails. And after that, we have this email service is using external system. So this is the third level. So when it comes to this level, we all we already have a blueprint of the system, which we don't have to think where we are going to put this utility in here, where we are going to put this service, are we going to create a module for this, things like this. It's visible in here, and we have to think it before we start coding. So once we are in here, the next level is coding. Usually code diagram is not done, as I explained earlier. So if it is needed, these days there are modern toolings that we can use for it. And also with the trend, AI trend, we can use the diagram to feed an AI and ask them to draw a coding diagram also. Or else we can use a paid service like GitHub Copilot and let him analyze the code and generate a code diagram. So usually this part is not done before doing the code because it takes a bit of time, and we can utilize that time to do the coding, and it is not very beneficial for business parties. It is only beneficial for people who are involved in the development and architectural decisions. So that's about the C4 model, how we are going to do this diagramming. And at the end of the diagram, we are going to have a diagram like this, which is the deepest level that we can go, and developers can refer this when they are starting the developments. And this is the component diagram, and we can use the container diagram to explain a new developer, or else, like, let's say, a QA engineer, a business management person, to explain about the components that we are using. And we can use this to explain to a DevOps engineer about the components that we have in the system, so that he can know how to do the deployment strategies and all. And then we have this context diagram, which we can show the business people to understand what this system and what are the external services that we are using. And also we can use this to show external audit persons, to let them know how our data is managed inside our system or outside our system. And yeah, that's how C4 model works. So let's now discuss about the benefits of using C4 model. The clarity and simplicity. As you can see, there are only 3 steps that we need to worry about. A 4th step is optional, which we can benefit from in special cases, and it's very clear for every people that is involved in this in a software development system, software system development. And the scalability. Uh, since we have the whole architecture with us, so we can always predict uh, with the direction of the system. We can predict what kind of features that are going to be integrated into this system, and we can be prepared for it. Because before we start the development, we are going to draw the architecture. So in that way, we will know the structure before starting the coding, and we can be prepared for it. So in that case, we have the system. What we have to do is we just take the diagram and we update with whatever we need to do the scaling part, and scaling uh, in terms of features. We can do the upgrade, and also in terms of load scale. Let's say the users of the system increase about 100 times. So since we have the architecture beforehand, we can decide how many users are we, what is the audience we are targeting. According to that, what is the level that this can go in terms of load performance and load balancing. We can decide what kind of performance it's going to need, or scaling criteria it's going to need when it's at the maximum scaled level. So we can decide what are the measures that we are going to take, and how we are going to scale it without too much cost, and on-demand scaling, things like that. We can decide with this C4 model. And the consistency, same as I explained earlier. Since we have this diagram, we know how the things are going uh, in the code level, and we can decide where how to organize the folders, or let's say services, controllers, modules in specific places with according to the business direction, because of this visibility. So the consistency is highly increased. So, and we can use these documents for clear communication. So most of the system nowadays that were developed before about 10 to 15 years does not have a clear documentation. which can lead to very disastrous times because of the people who develop the system is changing their employer. So by following this C4 model architecture diagram, we can reduce that. We can directly give the documentations to people, and the explaining part is greatly reduced because it's very visible and very clear. It doesn't require any learning curve for to learn this C4 model architecture. And independent of notation or tooling, since this does not follow any strict notation or any specific tools to do that. As you saw the diagrams, it is very easy to draw by hand also. So in the because of that, so uh, it is it is very easy to embrace this system and implement it for an existing system also, and it doesn't take too much time to learn these things and apply it into your development process. So in the conclusion, uh, the key points are: system architecture is a foundational to software development, and C4 model offers structured approach for visualization. And well-designed architecture yields benefits across life cycle and actionable insights. Invest in robust architecture to drive project success. Zoom into the lowest possible bottom. So that's it for this week TikTok. And thank you all for joining. Uh, Please send your feedback using this QR code. Thank you.